Hello, ladies and gentlemen. Welcome once again to our virtual classroom. Today, we are going to be going over how to solve addition equations. Again, that is solving addition equations. As usual, if you need time to copy the notes down at any point, really, please feel free to pause the video and then resume, rewind, resume. I highly encourage it, especially if you need to hear something over and over again. I realize it can go quite fast sometimes. But anyways, let's begin. Firstly, if you're watching this on Friday, know that you do not have to do this assignment. This is going to be for Monday. So the submission is not even up on Schoology. I decided to hold off on that. Before we begin, let us review what an equation is. Remember, ladies and gentlemen, that an equation has an equal sign. It is essentially an expression with an equal sign. And I realize that up until now, many of you have, when you see an equal sign, you think of the answer, like, oh, something equals something else. However, ladies and gentlemen, and while that is true, another way of seeing an equal sign is simply saying that one side is the same as the other. The left side is the same as the right side. You're saying that these two sides are balanced. It doesn't matter what operation you're doing. If you see an equal sign, you are literally saying this side is balanced with this side. This side is the same as this side. This side is equal to this side. Okay, so that is an equation. Think of it as a scale. And again, before we continue with the lesson, I also want to review the term inverse, specifically inverse operations. Remember, inverse operation is simply the opposite operation. For example, if you have addition, the inverse of addition would be subtraction. If you have subtraction, the inverse of subtraction would be addition. Similarly, if you have multiplication, the inverse of multiplication is division, and the inverse of division would be multiplication. So these are things that I bet most of you guys know already, but we're going to be applying those things today. Specifically, though, we're going to be talking about addition. And since we're talking about addition, you're going to see that that is also going to involve subtraction. As I'm sure you've realized by now, subtraction and addition are two sides of the same cone, right? If you add, the opposite of adding is subtracting. If you subtract, the opposite of subtraction is addition. And then multiplication and division are two sides of the same cone. Whenever you're multiplying, you may be dealing with division. Whenever you're dividing, you might be dealing with multiplication. A really quick example of how you might see that with addition and subtraction is that when you add 3 plus 2, so again, I am adding, that's going to give me 5. Well, if I start off with 5 and I subtract, I do the opposite and subtract 2 from 5, that's going to give me 3. Or again, if I start off with 5 and I subtract 3, that's going to give me 2. Here you can clearly see opposites in action. How you can do the opposite of an operation to negate what you just did. All right, so moving on. So how do we solve addition equations? What do we mean by solving addition equations? Well, in algebra, ladies and gentlemen, typically you're going to find at least one variable. And whenever we say solve the equation, we mean, well, what is the value of that variable? Literally, what is the value of x, or x is equal to what? Or what is equal to x. That's what we mean by solving equations. And ladies and gentlemen, our goal, what we're trying to do when we're solving equations is always the same. That is this. We are trying to isolate the variable. Again, our goal when we're solving equations is always this. It is to isolate the variable. Isolate the variable. From now on, whenever you hear me say, what is the goal of the equation, or what are you trying to do with the equation, you will always say to yourself, isolate the variable. All right? And I'm going to keep saying that. I'm going to say it over and over again. I want you to dream about that phrase, isolate the variable, because that is so important. That is always what we're trying to do. So if you ever get lost, you're supposed to do something with an equation and you see a variable, just remember, isolate the variable, isolate the variable, isolate the variable. So what does it mean? What do we do? What does it mean to isolate the variable? Well, by now I'm sure many of you guys, having been through this ordeal known as COVID, uh, you are at least familiar with the term to isolate oneself. So if somebody has COVID, or if they think they might be infected, what they're supposed to do is they're supposed to isolate themselves, meaning they're supposed to be apart from everybody else. It means to be alone. It means to be by themselves for a certain amount of time, right? That's what it means to be isolated. Some of you guys in kindergarten, or I don't know, that might still be the case now, but if you ever got in trouble, you got put into timeout. And so if you find yourself in timeout, you are isolated from everybody else. You are by yourself. That is exactly what isolating the variable means. It means that we want to get to the point where there's nothing around the variable. And that's going to make more sense when you start seeing equations as having two parts. Okay, there's two parts. You can split an equation. Equation separates the left side from the right side. So we have the left side of the equation and we have the right side of the equation. So here in this problem, we have 4 plus x on the left side and we have 7 on the right side. Now, is the variable isolated? Meaning, is it on the left side or right side, but is it by itself? So here, clearly it is not. Because while x is right here on the left side, it is surrounded, or it is accompanied by a plus 4. So no, it is not by itself. If it was by itself, it would just be x, but it's not. There's a plus 4 there as well. So what we're trying to do, again, is we want to get rid of that plus 4. We want x to be there by itself. But before we do that, I do want you to observe this example that we find in this is actually a video that I did link on under resources on Schoology. So this is a part of that video. It's a really good video. It's a little long in my opinion, but I really like this example that they put on here. All right. Now, again, just like I said, you can think of an equation as a scale. One side is equal to the other. So here they're using a very similar equation to the one that we're using, not the same one, but they have x. Sorry. They have x plus 3, and that is equal to 7. And again, an equation means this is equal to this. This is the same as this. All right, whatever x, and then you add 3 to that, whatever that is going to be the same as 7. That's going to weigh the same as 7. That's the information that is given to us. But again, ladies and gentlemen, our goal is to isolate the x. We want to get to the point whenever we don't have x plus 3, we just have x on this side, and we want to know what that is the same as. All right. How are we going to do that? How are we going to isolate the x? Well, couldn't we just take the blocks and remove them? Couldn't we just say, let's just take these blocks away? Well, we could do that, but if this really is a scale, if I make the left side lighter, what's going to happen to the right side if I don't do anything to it? It's going to become unbalanced. The right side is going to remain just as heavy, and that's going to go down, just like a seesaw. If you've ever been on a seesaw with somebody and somebody gets down, what happens to the person that stays on there? They're going to hit the ground, are they not? Because they're still there. They're not going to change just because the person got off. So again, yes, I can take the 3 off. I can subtract 3 from the left side, but now it's not balanced anymore. It is no longer equal. It is no longer equal unless, ladies and gentlemen, I do the same thing to the right side. I take 3 off. Think about it. They're equal. X plus 3 is equal to 7. I take 3 off from the left side, but then I do the same thing. I take 3 off from the right side. Now they are balanced once again, and take a look at what is left over. I have an X on the left side, and I have a 4 on the right side. Ladies and gentlemen, X is equal to 4. X is the same as 4. X is balanced 4. That means that whatever X is 4. It's the same as 4. Now watch how that makes sense. If I put a 4 up here, isn't 4 plus 3 the same thing as 7? Yes, it is. It checks out. Now, it may seem a little obvious, but yes, this is exactly how we solve equations. In fact, let me do this one more time, just for those of you that are a bit lost, or just to see it again. Really, again, we start off with x plus 3. This is a scale. This is an equation. On the left side, I have x plus 3. And that is the same as 7. Whatever x is, when I add 3 to it, it's the same as 7. All right? So remember, to solve an equation, what you need to do is isolate the variable. So I want the x by itself, so I'm going to get rid of the 3's. I'm going to get rid of the 3's, or the 3. So I'm going to subtract 3. But if I wanted to stay balanced, whatever I did to one side, I must do to the other. So I'm going to take 3 away from the 7 as well, leaving me with 4. So that means that x by itself has to be 4 for this to work out. And that is the answer. X is equal to 4. Let's do the same exercise with our equation that we have in our notes, which again, is very similar to the one that's right there. I don't think I did that on purpose, but anyways, we have 4 plus x is equal to 7. 4 plus x is equal to 7. Remember, our goal is to isolate the variable. I will be asking you that quite a bit. What is the goal? It is to isolate the variable, to get the x by itself. So the x is here on the left side. On the left side, I don't want there to be anything except just an x. So how am I going to do that? Well, I'm going to get rid of that 4. Instead of adding 4, I'm going to do the exact opposite. Instead of adding 4, I'm going to subtract 4. However, in order for it to stay balanced, I need to take 4 away also from the right side, leaving me with 4 minus 4, which is nothing. So all that is left over on the left side now is x. Now it's isolated. And that is going to equal whatever 7 minus 4 is, which is 3. Let me do that one more time with a little bit more detail. Again, we're trying to solve the equation. Let's isolate the variable. How am I going to isolate it? I'm going to use the opposite operation. All right. So here's a little bit the same problem, but with a little bit more detail. All right. So here we have x plus 4 or 4 plus x. They're the same thing. I just rewrote it so you could see it a little bit easier. It's the exact same thing. X plus 4 and 4 plus x is the exact same thing. So x plus 4 is equal to 7. Got it. All right. So again, we need to isolate the variable. We need to isolate the x, get the x by itself. How am I going to do that? I'm going to use the opposite operation. All right. So instead of adding 4, that's what I'm doing to the x right now. I'm going to take 4 away. I'm going to subtract 4 because 4 minus 4 is 0. So all that I have left over is just x. And that's fine, except, ladies and gentlemen, we must remember what I'm going to call the golden rule of algebra, the golden rule of equations. What you do to one side, you must do to the other. Remember, an equation means that it's balanced. If I do something to one side, it will no longer be balanced unless I do the same thing to the other. So as I took 4 away from this side, I'm going to take 4 away from this side as well. The only reason I'm taking this 4 away is because I need it to isolate the variable on the other side. Whatever you do to one side, you must do to the other. What you do to one side, you must do to the other. If this was a test and all of what it said was what you do to one side, the right answer would be you must do to the other. Okay? If I ever greet you and I just call out your name in class and say, hey, what you do to one side, you're going to respond, you must do to the other. That is the golden rule of equations. All right. So again, I want to isolate the x, so I'm going to get rid of the 4 by subtracting 4. The opposite of adding 4 is subtracting 4. But whatever I do to one side, I must do to the other. So now on the left side, all that is left over is x, and that is equal to whatever 7 minus 4 is. So x is equal to 3. Now, ladies and gentlemen, let's check it. Realize how much sense this makes. If I know what x is, if x has to equal to 3, well, let's put it back into the equation. Let's rewrite the equation. 4 plus, but instead of an x, I'm going to put a 3 now. 4 plus 3 is equal to 7. Is this a true statement? Yes, because 4 plus 3 is 7, and 7 is the same as 7. It checks out. Ladies and gentlemen, x is equal to 3. That is my answer. All right, for those of you who missed it, or if you want to see it one more time, again, x plus 4 is equal to 7. I'm trying to isolate the variable. I want the x to be by itself. How am I going to do that? I need to get rid of whatever I'm doing to it. So I need to get rid of this plus 4. The opposite of adding 4 is to subtract 4. All right, so 4 minus 4 is 0. And now it's isolated, except that whatever I do to one side, I must do to the other. So I need to take 4 away from the other side as well. 7 minus 4 is the same thing as 3. Ladies and gentlemen, x is equal to 3. How do I check that out? I can put the 3 back up here. Is 4 plus 3 equal to 7? Yes, x does equal 3. And that's it. Let's try one more. Here we have 5 plus x is equal to 9. 5 plus x is equal to 9. Again, what is my goal? Isolate the variable. All right. How am I going to do that? Well, I'm going to use the opposite operation, the inverse operation. Notice how I'm adding in this problem, ladies and gentlemen. I am adding. What is the opposite of adding 5s? Okay, because I want to isolate the x. I want to do the opposite of what I'm doing to it. So the opposite of adding 5 is to subtract 5. So I'm going to take 5 away because 5 minus 5 is 0. All that is left over on the left side now is x. It is now isolated. Awesome. However, again, whatever to do to one side, I must do to the other. So I'm going to do 9 minus 5. 9 minus 5 is equal to 4. That is my answer. How can I check to see that it's true? Well, instead of an x, I'm going to use 4 now. All right, so 5 plus 4, not 5 plus x, 5 plus 4. Let's see if that's equal to 9. 5 plus 4 is 9. It checks out. Ladies and gentlemen, x is equal to 4. Let's do one more. 12 plus x is equal to 23. 12 plus x is equal to 23. Notice that I am adding. Notice that the x is not isolated, but I want it to be isolated. All right. So I want to isolate the variable. How? I'm going to do the opposite operation. So instead of adding 12, I'm going to subtract 12. But whatever I do to one side, I must do to the other. So as soon as I subtract 12, I'm going to subtract 12 from the other side also. 12 minus 12 is 0. Hence why the variable is now isolated. That's why I have x by itself. And then 23 minus 12 is equal to 11. Therefore, x is equal to 11. How can I check it? Well, let me put the 11 back into the equation. Is 12 plus 11 equal to 23? Well, let's try it out. 12 plus 11. 1 plus 2 is 3. 1 plus 1 is 2. Ladies and gentlemen, it checks out. This is a true statement. X is equal to 11. We're going to do a lot more of these later, so I'll save the last example for Monday. Ladies and gentlemen, these are not difficult, but you have to understand what we're trying to do. We're trying to get the variable by itself. We're trying to isolate it. How am I going to do that? I'm going to do the opposite operation of what I'm doing to the x already. And then whatever I do to one side, I'm going to do to the other. All right. I hope that was helpful, ladies and gentlemen. And I will see you on next time, at the next time. See you later.